Bismillahirrahmanirrahim. Assalamu alaikum. Myself Nabiha Naveed. I am the student of University of Management and Technology from Chemistry Department BAR 003. Today I am going to discuss about wind turbine or we can say that how wind turbine can produce energy. So let's start. First of all, we discuss about the introduction of wind turbines. Wind turbines are firstly used as a windmill to produce electric energy in 1888 by Charles F. Brush. These wind power program also in India which can be started during 1983 to 84 with the efforts of Ministry of Non-Conventional Energy Sources. Wind turbine is a device that converts kinetic energy into electric power. It can be created when the atmosphere is heated unevenly by the sun and some patches of air become warmer than others. These patches of air rise and which can be replaced by other rushes and wind blows. It works opposite to the turbine blades which spin from the wind and make energy instead of using to make winds. Okay, these are the basic component of wind turbines. So let's discuss them one by one. So first component is foundation which provide the basic support to wind turbine. It consists of solid concrete assemblies. Then tower connect the rotor and foundation together and operate rotors according to the requirement of wind. These tower made up of steel having tube-like structures. Then rotor or rotor blades. It is a rotating part of wind turbines which convert wind energy to the rotations. These rotor made up of glass fibers, carbon fibers or reinforced plastics. Then nacelles. Nacelle is the basic component of wind turbine in which include gearbox, yaw system or electric generators. And these rotors of wind turbine connect with rotor hub to the gearbox with the help of low speed shaft and drive the electric generator by rotating high speed with the help of high speed shaft. Then gearbox convert rotor motion from low speed to high speed. Coupling is done when the main shaft is connected with the transmission, and when these shafts rotate it generate electricity with the help of generators and controller. Then controller is self-operating system used in control system. It may be sensor which may be mechanical or electrical. Then decision elements relays microprocess or we can say that in control system hydraulic or electric system also used. Yaw mechanisms are basically turns nacelles with the rotor into winds using motors. Our anemometer or wind vane measures the speed and directions of the wind while sending signals to the controller to start or stop the turbines. Now we discuss how wind turbine can work. Basically, winds blow and turbines convert kinetic energy into mechanical energy, which can convert into electric energy with the help of gearbox. We spin a generator to produce electricity, and then transformers convert electricity to appropriate voltage, and these electricity can then be stored or transported to grid for distribution. Okay, next. First of all, if we talk about the function of wind turbines is used to blades of some shapes which can vary to catch wind in kinetic energy. As these wind blow over the blades, it lifts them just like it lifts a sail to push a boat. That push from the wind makes them blade turn, moving the drive shaft that they are connected to it. These shafts can turn or run the pump of some kind, whether directly moving a piece of stone over grain or pushing that energy into generators that electricity create, which can create electricity that can be used to right way or stored in a battery. Then there are four major steps including in this process for producing or generating electricity from wind turbine. First step is wind push blades, in which basically wind turbines is located a place with regular and consistent wind. That air movement pushes specially designed blades that allow the wind to push them as easy as possible. Blades can be designed so they are pushed upwind or downwind of their location. Second step is kinetic energy is transformed. Kinetic energy is free energy that comes from the wind, so it is very easily able to store that energy. It needs to be changed into unusable form of power. Kinetic energy is transformed into mechanical energy when they meet with wind, that windmill blades, and push them. The movement of the blades then turns a drive shaft. The third step is in which electricity is generated during a wind turbine or spinning drive shaft is connected to a gearbox that increase the speed of rotation by factor of 100, which is turn spins a generator. Therefore, the gears end up spinning much faster than the blades being pushed by the wind. Once these gears reach a fast enough speed, they can power a generator that produces electricity. Here we talk about the gearbox, which is most expensive and heavy part of turbine, and engineers are working on direct drive generators that can operate at low speed so they don't need a gearbox. Next step is in which transfer mechanical energy is converted into electricity. The electricity produced by generator in 60 cycles AC current means alternating current electricity can be produced. A transfer may be needed to convert that to another type of electricity depending on that local needs. And next and last step in which electricity that is generated can be stored. Electricity that produced by wind turbine might be used on different sites, most likely to be true in smaller medium-sized wind projects. It could be delivered to transmission lines for use right way, or it could be stored in a battery. More efficient battery storage is a key for advancement in wind energy that can be used in the future, which increase the storage capacity means that on days when the wind doesn't blow or less blow, the stored electricity from winter days could supplement it. Wind variability would then become less of an obstacle from reliable electricity from the wind. Now we discuss about types of wind turbine. These wind turbines basically can be divided on the basis of forces. Some wind turbines are processed by using lift force and other are using by the drag force. So first of all, horizontal axis type wind turbine in which the blade rotate on an axis parallel to the ground. There are further different type of horizontal wind turbine. First one is single blade horizontal wind turbine. Second one is two blade horizontal wind turbine. Third one is three blade horizontal wind turbine. If we talk about single blade horizontal wind turbine, in which lower blade weight and less cost blades are used, in which more vibrations and unconventional looks. Then come to the two-blade horizontal wind turbine. It is almost similar to the single-blade horizontal wind turbine. Only the difference is the stability problem. And the last one is three-blade horizontal wind turbine. It is in which the balance is appropriate because of cryoscopic force, which increase gearbox cost. It is most cost. It is expensive and most efficient. Uh, and come to the second type of wind turbine, that is vertical axis type, in which main rotor shaft arranged vertically and runs according to the wind direction. It further divided into two types. First one is Darius wind turbine and second one is Savinus wind turbine. Darius wind turbine is relatively have good efficiency and produce large torque. Cycle stress on the tower requires some external power source to start turning. But in Savinus wind turbines, it is basically type of drag type turbine. It is self-starting and less efficient and used in the cases of high reliability in many things such as ventilations and anemometers. Now we discuss about the sizes of wind turbine. Some wind turbine are small that use in homes, farms, remote applications, for example water pumping. It produce almost 10 kilowatt energy. Then if we talk about the intermediate turbines, it produce energy about 10 to 250 kilowatt. It mostly used in village power, hybrid system, distributed power. So if we talk about the large turbine, it produces almost 250 kilowatt to 2 million watts in electricity. It mostly used in the central station wind farms or distributed power. If we can see at the systematic diagram, here we can see that as the size of wind turbine can be increased, the energy or electricity production can also be increased. Here we can also see that as the wind turbines are getting taller or bigger, it become more powerful. Wind turbine can be depend on five major factors. For example, wind power, air, temperature, obstructions, altitude, blade, aerodynamics. Next, if we talk about the site selection for the wind farm, consider during the site selection the most important things: the local ecology, nature of ground, nearest to user center, easy transport, availability, terrain and aerodynamic, altitude of proposed site, high annual average wind speed, can be considered during the site selection. If we talk about the best site of the wind turbine, where is the offshore and sea coast, where almost 2400 kilowatt energy per meter square produced annually. At mountains, 1600 kilowatt energy can be produced electricity, and if we talk at plains, there will be a 750 kilowatt per meter in electricity can be produced per year. So wind farm can be maybe offshores or maybe onshore wind farms. If we talk about the offshore wind farms, it can be located right off the coast or in sea using floating platform. More wind power and but more cost. It is very expensive. For example, in United Kingdom, London area where the wind farm can be implemented, it produces 630 million watt electricity. Onshore wind farm, it less wind power available than offshore, less cost in installation, usually near to user, but create noise and visual problems. For example, in Rajasthan, where the Jalemish wind park can be implemented. Here's some location of wind farm. Worldwide, there are now over 200,000 wind turbine operating with a total nameplate capacity of 318,105 milliwatt. Top 10 countries by nameplate wind power capacities are all given below in the table. And if we talk about in India, there are different cities where the wind energy installations are present. So for the safety of the system of wind turbines, first of all, emergency stop if in any situation which calls for the wind turbine to be stopped immediately, it is used, and wind turbine stop in few seconds by feeding the blade directly into the wind. Next one is computer and sensors. The wind turbine is also controlled by computer and data from sensor which monitor the most important gauging instrument and compare the result. If found error, wind turbine is stopped. The next one option is lightning rod. The wind turbine system is protected from the lightning by these rods going from the tip of the blade to the ground. The last one is temporary rope system in which fall protection during construction, maintenance or inspection of wind turbine. Here's some advantages of wind turbines. First of all, it is freely available in nature, can be combined with solar electricity to give reliable supply of electricity, and good for environment as it uses renewable sources of energy as wind. It can be set up in remote areas where electricity through transmission wire cannot be reached. Also, it a clean source of energy as it does not provide any greenhouse gases or any other pollutants. Once it is completed, the cost generation of electricity become also decreases. Uh, so here some disadvantages of wind turbines, which include it threats the wildlife like birds. It kills the bird when it process or it working. It also causes the visual impact. It is also expensive. It also cause disturbance in television and communication signals. It also cause problem in site specific during suited to particular region, create like a lot of noise disturbance. And the last one is prediction of wind is difficult when it is wind changes speeds. That's all from my side. Thank you. Allah Hafiz.